Number 80B. Number 80, the question is, what volume of a 0.5 molar HCl solution is needed to neutralize 10 milliliter of 0.2 molar barium hydroxide solution. This is 80B. Okay. I'll see what volume of 0.5 molar HCl is needed to neutralize 10 milliliter of 0.2 molar NaOH2. So first thing, always write a balanced equation between these two solutions, right? BaOH2 is a base. React with HCl. Since you have two hydroxide, then you must have two hydrogen to react with it, right? Produce two water. The rest is salt, BaCl2. Okay. So the mole ratio is 1 to 2, right? Okay. So barium hydroxide. Here your volume, here your concentration. What you can calculate? Concentration times volume is more, right? So 0.2 molar times volume is 10 milliliter. You can convert it to liter, or even you can keep use milliliter. If you keep use milliliter, the others still use milliliter, right? So this more concentration times volume is more moles. Is barium hydroxide moles. Based on this balanced equation, every 1 mole barium hydroxide needs 2 more hydrochloric acid, right? So times 2. Becomes more of hydroxide, not hydroxide, hydrogen, hydrochloric acid, sorry. Becomes more hydrochloric acid, and here also you volume. From moles, how can you calculate the volume? Molarity equals to moles divided by volume in liter, right? If we know moles, do we know molarity? Concentration tell you HCl is 0.5, right? Molarity is a known value. Moles, molarity, how can you calculate volume? Switch this two. Volume should be equal to moles divided by molarity, right? So moles divided by molarity in the denominator. Molarity is 0.5. Right? Mole divided by molarity give you volume in liter. So from here, you get 0.008 unit is a liter. The mole divided by molarity is a liter. That means you need 8 milliliter of HCl to react with 10 milliliter of 0.2 molar BaOH2. Okay. Oh, we need to go back. So again, molarity is concentration times volume. We convert 10 milliliter into liter. So molarity times volume is moles of BaOH2. Then use this balanced equation. Every 1 mole BaOH2 need 2 more hydrochloric acid. That's why you times 2. Then becomes more of HCl divided by molarity. You get a volume. This is our answer. What is the volume needed? That's number 80. Now take a look. 72 gravimetric analysis. Okay, this 80 is acid-base titration. 72 gravimetric analysis. The concentration of sulfate in water can be determined by adding a solution of barium chloride to precipitate the sulfate ion. Also, you write the net ionic equation. So barium sulfate, barium react with sulfate, produce barium sulfate precipitate. This is the net ionic equation. Treating 145 milliliter of water with excess barium chloride. So sample is 145 milliliter containing some sulfate there. With excess barium chloride. So barium is excess. Produce precipitate 0.33 gram barium sulfate. Okay, we collected the solid product with mass 0.330 gram. Also, based on this data, determine the concentration of sulfate in the original water system. This is a water sample. Have some sulfate there. So based on this, calculate sulfate in the water sample. Whenever give you mass, you always need to convert more, right? Because you're going to use a balanced equation. Balanced equation is a more relationship. So 0.33 gram barium sulfate. How to convert more? Divided by molar mass, right? How can you find the molar mass? Use a periodic table. You need to find the molar mass of barium and sulfur and oxygen. Right, barium here. 137.3, sulfur 32.06, oxygen 16. You need to have 4 oxygen. 16 times 4 plus sulfur 32.06 plus barium 137.3. And all these together is 233.3. So So this mass becomes more. And we want to figure out the concentration of sulfate. So we need to figure out from this mole to this mole. New number means 1, right? So this mole should be same. So every 1 mole barium sulfate, you should have 1 more sulfate. These two are same. So up to here, we get the moles. For moles, together with volume, we can calculate the molarity. And mole divided by volume, but the volume must be in liter. So divided by volume in liter. How can we convert this into liter? Oh, 3 decimal place. Divided by 1,000, right? 0.145 liter. So 145 milliliter divided by 1,000, just move 3 decimal place, become 0.145 liter. And this is the concentration. 0.00975. So this is the molarity of sulfate. Are you okay with this? This is 72 gravimetric analysis. Now, let's take a look at another one. 66 is a dilution problem, sorry. Okay, that's what we learned today. 66, dilution problem. Okay, dilution problem. The question is, you have 505 of 0.12 molar, 125 molar HCl. 505 of 0.125 molar HCl. And you want to dilute it to exactly 0.1 molar. Point 1.125 molar HCl, want to dilute to 0.100 molar HCl. Ask you how much water should you add? Right. We add some water, becomes 0.1. Okay, it's dilution problem. Dilution problem, what is the equation? Do you remember? You just learned it today, right? MI/VI equals to MF VF. Right. What is MI? Initial concentration. What is VI? Initial volume. What is MF? Final concentration. Then we can calculate the VF, right? VF don't know. So MI/VI equals to MF VF. From here, the VF equals to both sides divided by MF, right? MI/VI divided by MF. MI 0.125. VI 505 milliliter. MF is 0.1. you find the molarity cancelled, leftover milliliter. So if you use milliliter in VI, then what you calculate the VF is still milliliter. So this will be 631.25 milliliter. But this is not your answer, because the question answer is how much water should you add? And this is the final volume. Final volume is total volume. You initially have 512 milliliter acid already, and you want the final volume is 631.25. Then how much water you need to add? Of course, the difference between these two, right? So the volume of water you should add is final volume minus initial volume. 126.25 milliliter. So this is water you need added to hydrochloric acid in order to dilute concentration from 0.125 to 0.1. Okay, can you understand this question? You need to understand what I asked. Here asked is how much water should you add, not ask you find the volume. So you need one more step. Now take a look, 39. 39 also show you 1. 39 show you 1. Let's say 8. Where is it? Even worse. Let's say, yeah. Let's say 8. 39 for each complete redox reaction break down into half reaction, then identify oxidizing agent and reducing agent. Okay, let's say A the reaction is strontium react with oxygen, produce strontium oxide. Also, you break down its equation into half reactions and identify oxidizing agent and reducing agent. Half reaction, that means each reactant, right? We have 2 reactants. So one is strontium becomes what? This is strontium iron, right? This is ionic compound. Strontium iron, what is the charge? It's strontium group 2A. Plus 2, because oxygen negative 2, right? Mostly negative 2. Strontium group 2A always positive 2. How can strontium matter? Matter is no charge. Free matter, no charge. Becomes strontium iron, lose 2 electron, right? From 0 to 2 plus means lose 2 electron. Then 2 strontium lose 4 electron. Matter always lose electron. Okay. And where these 4 electrons go? Gained by oxygen. This 4 electron loss from matter gained by oxygen molecular. So oxygen becomes oxide. Oxide is -2. Each oxygen gain 2 electrons becomes -2. So 2 oxygen gain 4 electrons. Becomes 2O2 minus. Okay. So this is half reaction. Lose electron we call half oxidation reaction. Gain electron we call half reduction reaction. Then which one is a reducing agent? Which one is oxidizing agent? Which one? Strontium, yes. Reducing agent always matter. You remember, right? Reducing agent always matters. Strontium. Oxidizing agent. Oxidizing agent could be non-matter, could be matter ion. For this case, non-matter, right? Because the other one is oxygen. Oxygen always oxidizing agent. This name comes from oxygen. So oxidizing agent generally could be non-matter, like here, oxygen. Could be matter ion. Sometimes matter ion gain electron, reduce it to matter, for matter. Oh, only 1 minute left. Okay, let's see, 1 minute left. Let's ask you number 9. Ask you, identify each of the following substances as strong electrolyte, weak electrolyte, or non-electrolyte. Let's see. 9. Is this a strong or non or weak electrolyte? Nobody know? Strong, yes. Okay. Whenever see alkaline matter, always soluble ionic compound, this strong electrolyte. How about this? This is not very easy, right? This is a weak acid. Weak acid, weak electrolyte. How about this? This is water, right? Very weak. How about this? CH2O, C2O, H22. Oh, 11, yes. How about this? This is sugar. What we normally eat, this is sugar, right? Non-electrolyte. Okay. Non-electrolyte, this means when dissolved in water, have molecular form, no iron. Stay hard during the weekend. We're how quiz 4, sorry, Monday.